Hi there once again and welcome to another Expresso mechanic tutorial. And in this one we're going to be rigging this contraption that you see on the screen. In order to make this work we're going to be building two Expresso expressions and they're quite involved. There's a fair amount in both of them. And the FlipFlop node is going to be a key player in both of those expressions. I've made the scene file available on this occasion and you can download that from the link that I've pasted in the show notes. But anyway, that's what we're going to be about in this tutorial. So without further ado, let's see if we can make this happen. The first thing we need to do is bring in a null. We'll rename it Expresso. Give it the Expresso tag. We've got our window open and we're ready to start work. Let's just make it a bit smaller initially. Okay. The first thing that we need to do is bring in what we've got down here, which is a drive shaft. Now this is obviously connected to a motor and it will be used to drive the bevel gear here, or the interrupted bevel gear. That's the job that it's doing. So we'll bring our drive shaft in, and at the input stage, or rather the output stage I should say, coordinates transform and it will be rotation B. So we need that port at the output stage. Moving on from here, we'll bring in a math modulo. So calculate math, bring this over here and we'll change the function to modulo. And the input 2 down here, that needs to be a value expressed as 6.283. And that will be radians for 360, because we want to only work with values between 0 and 360. We want to reset as soon as this has gone through one revolution back to 0. So that's what we're doing with the modulo. Moving on from here, we'll bring in a degree node. So again, we'll come down to calculate degree, bring one of those in, place it after the modulo and connect the output to the input. And with regard to the degree nodes function, we will be going from radians to degrees, so we can leave that as it is. Our next port of call will be to bring in 4 compare nodes. So we've got our first one, and we can just command drag to create the remaining 3. And we've got those there. Fantastic, so we've got all that set up. And we can think about moving on. The first thing we can do is connect the output of the degree node to the input 1s of all of our compares. So we'll just get that done and then we can worry about setting the compares up. Our top compare, we can set that the function will be less than or equal to, so we can set that up and it will be 0. So we can leave that as it is. Our next compare here, we can set the function to greater than or equal to, and it will be minus, and we'll put 107 in there. We may need to adjust that later, but we'll just put 107 in there for now. And next one down, less than or equal to for the function, and it will be minus 182. And then finally, oops, don't want to do that. Finally, with our fourth compare, our function will be greater than or equal to, and our value minus 289. So we've got those set up. Now, what are we doing here? Well, we can see what's going to happen. When the actual interrupted bevel gear is rotating, at certain points in time, it's going to be moving the top bevel gear in an anti-clockwise or counterclockwise direction if you're in America. And at other times, it will be moving the bottom bevel gear in a clockwise direction. But when it's between the two states, these two things are going to be standing still. That's exactly what's going to be happening. So our first value here, we've got less than 0. Well, that makes sense. If we select the drive shaft and we go into our coordinates here, we've got rotation B and it is at 0, but if we move it then it's going to be less than 0, so we're going to need to start moving this bevel gear here. And if we look at 107, if we place our drive shaft at -107, we can see that that's basically at the end of one cycle. Okay, cycle, I suppose, is quite a good word to use, really. So that's dealing with that. Now, if we go down to here, we've got -182. So let's set this to -182. And we can see that we're at the beginning of the next cycle. So we're just about to start moving our gear here. And if we go to -289, we can see that we're at the end of that cycle. We've come out the other side. So that's why we're setting this up in the way that we're setting it up. Okay. Those are our key values. They're very important values. So we'll set that to 0 and we'll carry on from here. The next thing we need, we're just going to make the window a little bit bigger. The next thing we need are a couple of range mappers. So once again, we'll come down to our calculate menu and grab a hold of a range mapper. Put this one up here, command drag to copy, and drop this one down here. And on this occasion, I'm going to be plumbing directly out from the modulo, not the degree node. So we're going from here to here and here to here. Now, our range mappers, we need to set those up. So first thing we need to do, in fact, we'll select both of them because this applies to both. So shift select them. We need to, with our input range, make this degree and our output range degree. And then we can think about working with these individually. So our top one, our input lower, it does need to be 0. Input upper, -107. Our output lower will need to be 0. And our output upper, 107. So that's our first range mapper dealt with. We don't need to worry about the spline. We're not going to bother with that on this occasion. Our second range mapper, our output lower needs to be -180. Our output, or rather our input upper, needs to be -289. Output upper, or rather output lower, I beg your pardon, needs to be 107. And our output upper we can set to 0, but if we do, we'll get a problem, and we'll need to set that to -1 on this occasion. Okay, so those are all set up and they're ready to go. Moving on from here, we can think about our next step. And that will be to bring in 2 bools. So we'll bring in the first one, place it here, command drag to copy, and place our second one in here. And we can connect the outputs of our compares accordingly. So these 2 into this one and these 2 into this one. So when we're between these 2 states, so 0 and -107, we're getting a positive output from this bool. And similarly down here, when we're between -182 and -289, we're getting a positive output from this bool. And that will enable us to control what we're going to do next. Moving on from here then, we'll bring in 2 condition nodes. So logic condition. Bring the first one in, and once again command drag to copy, put our second one down here. So we've got those 2 in, and we can worry about connecting them up. Now, the output of our range mapper here can be connected into the input 3 of our condition here, and similarly down here we can do the same. So that's those 2 connected. In order to switch them, we're going to be using the bools. So the output of this one will be used to switch this one, and the same down here with this bool. So that's our switching sorted out, but we've still got input number 2 to worry about for both of these. Now, what we need there is to bring in the bevel gear shaft. So we'll bring that in, and that is this object here that connects these 2 bevel gears together. because that's what we're going to be working with. We're going to be actually applying the output of our range mappers to this object as opposed to either of our bevel gears. So we need its rotation H. So transform, rotation, rotation H. And we can connect that to both of these inputs. So what we're doing, or what we will be doing here, is when checking our states. And when we're between either of these two states, we want to be able to move our drive shaft, or our bevel gear shaft, I should say. We're going to be using our bevel gear or drive shaft to actually move our bevel gear shaft when it's between two specific states. And that's where the range mappers come in. So when we're between the states, we use the bool to switch the conditions to allow us to use the range mappers, and at all other times we want the bevel gear shaft to stay where it is. We don't want it to move, and that's why we're using this in the input number 2s of our conditions. That will actually make that happen. Fantastic. So in order to synchronize all of this, we need the all-important node, and that will be a flip-flop. So we'll bring one of those in. Now you've seen me use these before, and mostly I just plumb something into this switch. Well, on this occasion we need to use the on and off inputs. So it's a little bit different, and in order to use those, what we need to do is plumb the outputs of our bools in like this, and that will allow us to switch between the two states. So when we get a positive output coming into the on switch, we're going to get a 0 at the output. When we get a positive output into the off switch, we'll get a 1 at the output. So it'll allow us to alternate between two states. In order to make use of that, we need a few more nodes. So we'll bring in another condition. In fact, what we'll do, we'll command drag to copy this one, bring it in here, place it down here. Now, the output of the flip-flop is going to drive the switch. So we've got that there, and then we need to set up the inputs. And our top condition here, we're going to be plumbing into this input number 3 here, and the condition here goes into input number 2. So that's how we set that up. Okay. So that will allow us to use our top and bottom range mappers or our bevel gear shaft as need be. And then in order to get this all to hang together, there's a couple more things we need to do. For a start, we need to make sure that when we're at the beginning of the animation, that the drive shaft, or rather the bevel gear shaft, is set back to its 0 position, so the position that it's in now. We always want that to be the case at the beginning of the animation. So we'll bring in a time node. As per usual, I'll just remove the time port and put a frame port in. We don't necessarily have to, but I'm going to do that anyway. So I've got my time port in. I need another compare, so I'll just bring one of those in. Logic compare. It is set up as it needs to be, so equal to and 0 in the input 2, that's fine. Connect the frame port, and then we simply need one more condition, so we'll bring that one in. This will be used to switch it, and we need to simply plumb this condition into here, because when we're at the start of the animation, we'll switch to our input number 3, and it is 0, and that's exactly what it needs to be, so that we can 0 out our bevel gear shaft. So we just need one more node, and that is the bevel gear shaft. So bring that in, and at the input stage, give it a rotation H port, and then we can plumb this into here, and that completes our first expression. So let's have a quick look and see what we've got. I mean, it's quite a nice expression, this one. Again, I'd say it's quite involved, but all it really allows us to do is check to see what's going on with our, if we just hit H so we can see all of it, with our drive shaft. And when it's between two states, we know that we need to switch to use our range mapper if we need the bevel gears shaft to move, and it will either move in an anti-clockwise or counterclockwise direction or a clockwise direction. And at all other times it will just remain in its current position, which will either be here or over here. This will swing through this arc and it will rotate to over here. So that's all this is doing. It's just allowing us to synchronize all of that. In order to make it work though, we need to actually keyframe the drive shaft, and that's going to be our next port of call. We'll just shut this window. Now I've got 600 frames set up here, and at frame 0 I want my drive shaft to be at 0 degrees, so we'll put a keyframe in there. Don't really need those. Let's just select that and keyframe that. That's better. And then we can skip through to the end and set this to minus 3600 degrees and put a keyframe there. And let's just test this and see if it actually works. And we can see that it does. What I want to do is just go into my timeline F curve, and we'll set this to a linear curve. Don't really want it as an ease out, ease in curve. Right, let's just see what happens. And we can see that that's working. Right, let's just make sure that we've got 600 in here. Where are we? Oh, sorry, it's here. 600. That's what I want to do. That's what I want to do. Let's see what we get. And there we go. We can see that that's working beautifully. Really beautifully. Yeah, I mean, we're getting exactly what we want. So we've got our first expression well and truly complete, and it's doing exactly what we want it to. So moving on from here then, we can think in terms of making these two platforms that support the letters E and M move up and down as needs be, because the idea of this is that these two objects here are light dependent resistors basically, so when the spoon is over them the light disappears and it triggers them to make these things work. That's the concept behind this. And in order to do that, we're going to use a second Expresso expression. So once again, we can come up to our null here, give it an Expresso tag. We've got an empty window, and we're ready to start thinking about building our next expression. The first thing I'm going to do is reach for a time node. So we'll bring one of those in. And on this occasion, I need a time port and a frame port, and you'll see why a little bit later. But we've got that there, and we're ready to take the next step, which will be to bring in a compare node. So we'll bring one of those in. And on this occasion, we need to say the function is less than, and it will be 17 for the input 2. Okay, and then what we need to do is connect the frame port to input 1. So when we're less than 17 frames in, we want something to happen. Okay, and in order to make that happen, we need to bring in a compare, or rather a condition. We've got the compare, we need a condition, so we'll drop that in there and drop this here just to switch that to this input here. Now initially I don't want anything to happen when this makes its first move. So when this spoon object here is swinging across to here, so let's just play the timeline. When it does this, I don't want anything to happen with either of those. If I didn't do this next step, we'd get a glitch and funny things would start to happen. So that's why I'm doing this next step. Now up here, I've got a dummy object, and what that is just a sphere, and it's a tiny little sphere, and it's located within the drive shaft so that we never see it. So if we bring this dummy object into here, and we also bring in our spoon, let's see where we can find that. Let's have a look, see what we've got down here. So in our bevel gear, we've got the spoon, and we'll bring that spoon in and drop that up here. All we need to do is give both of these object ports, so we'll do that. And that means that this condition will need to be set up with a different data type, and that will be a link type. So we need to do this, okay? And then all we need to do is connect the spoon to input number 2 and the dummy to input number 3. So you can see that when we're less than 17 frames, we're going to be passing the dummy through this condition. Okay, so that's going to be really important, because the dummy isn't going to be doing basically anything with regard to what's going to be happening next, and you'll see what we're going to do there. So let's move on and bring in the next nodes that are going to be important, and they're going to be ray collision nodes. So we're going to come down to a general menu, ray collision, bring one of those in, command drag to copy, and we've got a second one. Okay, and we'll just make this window a lot bigger so that we can set things up. Let's just move this down here and move this down here. Okay, fantastic. So our output port here, it's either going to be the spoon or the dummy. That's what we're going to be passing to the object port. So we'll connect those two up, and we've got those there. Now, both of these are currently in test only mode. We don't want that. Just take the test only off. We'll leave the global coordinates. That's fine. And then we can worry about what we're going to be plumbing into the ray point 1 and 2 ports. So let's see where we are. We can just close this up. And if we go into these two, which are our letter M's light dependent resistor and our letter E's light dependent resistor, we can see that we've got 2 null objects. Now, if we just have a look at where these are, if we select them, we can see that we've got one here, and if we select the second one, it's within the actual LDR. So we've got one above the spoon and one below the spoon, and we've got the same over here. So one here that's above the spoon, one here that's below the spoon. So the way the ray collision works, of course, once you actually break the beam, because these 2 objects are actually generating an invisible vector between them, like an infrared detector. That's how this works. So once that infrared beam, if you like, has been broken, then something is going to be, well, the collision port here is going to produce a 1, basically. It's going to be a true output. So what we need to do is bring in the various objects. So if we get these 2 first, just bring these 2 in, place them here and here, and they need global position ports at the output stage. Okay, and then we can just make them bigger so that we can see what they're doing, and then we can connect these 2 up, so we can connect them to ray point 1 and ray point 2. And the same applies to T3 and 4 here. Just bring them in, global positions at the output stage, make them a little bigger, and then connect them to the ray point 1 and ray point 2. And they're all set up and ready to go. Fantastic. So we can see that once we're above 17 frames, the spoon is going to be passed. And basically what that means is as soon as the spoon has swung over to here, that takes 17 frames. That at that point, we're going to be using the ray collision nodes in the proper way. I mean, initially, they're just going to pass out a 0 from here because the dummy object won't do anything. But as soon as we're above 17 frames, they're going to have the ability to pass a 0 or a 1. That's exactly what we've just set up there. So that's what this is for. Fantastic. So let's move on and think about where we're going next. From here, we need 2 monoflops. So we'll bring in 2 of those. We've got our first one, command drag to copy, and we've got our second one. Put this one down here and put this one here. We also need a FlipFlop, and we may as well bring that in now. So we'll grab a hold of that and we'll place it in the center. And we can think about connecting these up. Now, for a start, we need to worry about the durations. So both monoflops, if we select them both, so shift select, the durations needs to be 34 frames. Okay, that's the duration for both monoflops. And then we can think about our triggers. Now, they both need to be triggered in the same way. So they need to be one-shot monoflops. So we've got those 2 there because we know that when we're getting a 1 out of here, we need to trigger them. And that's going to be the same for both of them. So we'll connect this one and this one to the triggers, and then we can think about where we're moving on from here. Now, again, this collision will also be plumbed into the on switch and this one into the off switch. So we've got a similar situation to the flip-flop in our previous expression. So that's those parts of this set up. We then need to use our time port. So we can bring this into here and we can also plumb it into here. And that's all of those set up and ready to go at the input stages. Now at the output stage of the monoflop, we simply need to add state ports. Let's just make that a little bigger. So we put the state ports in and then they're ready for the next step, which is going to be to bring in some more range mappers and a few more bits and pieces after that. So let's just get the range mappers first. We'll bring in, as we did before, a single range mapper, place it up here, and then we'll command drag to copy so that we've got those. If we command drag with both selected, we've got those down there. Okay, so we've got things set up thus far. We can now think about what we're going to be placing into each of our range mappers. Let's select them all and we'll deal with the spline first. I think that's the easiest thing to do. What I'm going to do, I'm just going to put 2 points in here and drag the second one to somewhere around here, and we can just twirl this open and make this 0.6. That's the shape I want, and I will also say minus 0.25 there. So that's the way I want the splines set up, because what I want to happen, we just move this out of the way, when these raise up, I want them to pause, and then when they go down again, the opposite thing is going to happen, really. So that's what we're doing here. So let's continue from here and then work on the numbers. So we'll start from the top. Now let's see where we are. So this first range mapper, we're going to be dealing actually with the M's plinth, which if we just open these two up, we can see the plinths in here. So the M plinth is currently at 0 on its y-axis. It's the y-axis, of course, that we're dealing with. If we just select the E plinth, we can see that that's at 99. So that's at its finish position, effectively, or its maximum height. And this is at its minimum height, so the M's down at 0. So our first range mapper then, we're going to be dealing with the M. It's always going to be the case that the input upper and input lower values will be 0 and 1. We don't have to touch those because they're receiving what's coming out of the state port, which is of course a 0 or a 1, or a value between 0 and 1, I should say. So we've got that set up that far, and we can move on to think about what we're doing with the output lower and upper. Well, on this occasion, the output lower will be 95 and the output upper 0. So that's our first range mapper sorted out. Now our second range mapper is dealing with something else. It's dealing with the E. So it's dealing with the plinth that we've got here. That being the case, we need it to be a value between 0 and 99. So a value between 0 and 99, we've got those in there. Coming down to our range mapper here, this is going to be dealing with the E. So it needs to be 99 to 0. And then finally, this one's going to be dealing with the M, and this needs to be 95 to 0. Okay, so we've got those set up. Now let me think. One of them is wrong because I've got 95 to 0 in there and I've got 95 to 0 in here. This needs to be 0 to 95. And that's correct. Great, so let's move on from here. Now, earlier we set this error trap up. And we need a similar error trap down here because we want this flip-flop to only start producing 1 and 0, or a 1 or a 0, after 17 frames have elapsed. So we don't want anything changing in here initially because, again, it will just cause a glitch in the animation. We don't want that. So let's bring in another condition. We'll command drag to copy this one. It changes data type to a real value so that that's ready to go. And just place it here. Now we're going to control this by, once again, the output of this compare. So we'll plumb that into the switch and it's ready for us. And then we can take the output of here, plumb this into here, and we can leave input 3 as 0 because that's what we're going to leave it at. So we're going to make it 0 at the beginning of the animation until we get to frame 17. Okay, so that's set up and ready for us. Moving on from here, we can command drag to copy 2 more of these and just set them up here. And then we can think about how we're going to work with these. For a start, we're going to be switching them with this condition. So that's that part of it ready and sorted out. And then we can think about plumbing our range mappers in. Now, the output of our top range mapper here is actually going to be plumbed into the bottom input of our second condition. And the output of our second range mapper will be plumbed into the bottom input of our top condition. So we've got those two sorted out. And then it's basically the direct opposite with these two. If we plumb the output of this range mapper into the input 1 of our condition here, and then plumb the output of our range mapper down here into the input 1 of our second condition, we've now got it set up as it needs to be. And we can now alternate between raising and lowering the E and the M. So when the E is going down, the M is rising, and vice versa. That will allow us to do this. That's what we've just set up there. Fantastic. In order to finish off, let's just make our window considerably bigger so that we can see a lot more of our expression. In order to finish off, again, we need to set up a situation where we can bring the E to its current position and the M to its current position at the start of the animation. So once again, we will need to reach for a compare node. Command drag to copy, and once again we'll use the frame output here. We'll just plumb this in here. Just bring that level, actually we'll bring it level with those, that's fine. And we can say is equal to for the function, and it will be 0. So at the start of the animation. We can then think about where we're going next. Well, for a start, we need another 2 conditions. So we'll command drag to copy those and put them there. We will use this to control the switch. So at the start of the animation, we're going to 0 out. And that's all good. Or at least we'll 0 one of them out. We'll actually 0 the bottom one out. That will be 0. And this condition, we need to put 99 in there because we want the E to be at its raised position. We want it to be where it is now. Okay, so those 2 are sorted out. The next thing to do is plumb the outputs of these into the input 1s. And then we simply need our final 2 nodes, and we'll get those from the E plinth and the M plinth. So we've brought those 2 in there. At their input stages, we just need to give them position Y ports. So we'll do that. Position Y. And then all we need to do is connect the outputs of our conditions to the 2 position Y inputs. And that is our second expression complete. Let's just bring this over here. Make the window as big as it can possibly be and then hit H. And there you are, there it is. So once again, it is quite involved, but it simply allows us to alternate between making our E and M's E&M letters on their plinths, raise and lower at the correct times, synchronized to this. That's all we're doing there. And as I say, we've got a couple of error traps in there, and you know, those are there to prevent any glitching at certain points in the animation. So let's see what we get. Let's just close this down. Let's just play the animation. Let's just click off that so that we don't see it. Okay, so far so good. So we're getting something working as we expect at this moment in time. But let's just see what happens if we loop it. Let's see if there's any problems. Yes, there's a glitch. You can see there's a glitch there, can't you? So when you loop it, the E stays down when it should be raising. Now, the reason for that, let's just have a look and see where we are. What I found was that I needed, it's the age-old monoflop problem. If I was to put a result node in here and just connect this state to there, that should solve the problem. Let's just go back to the beginning, play again and see what happens this time. Well, so far everything's working fine. Well, I'm interested in when it loops. May not be an issue, but it's worth just showing you that there isn't, you know, a problem there if you do decide to loop the animation. There you go, we've looped, and this time we're okay. Yeah, it's really weird, that is. It's just one of those things that that happens with Expresso. I don't know why that is. It's something to do with the monoflop. What I should do as well is just swap these round, because this should be the first expression and this the second, although there doesn't appear to be a major problem with not doing that, but for the sake of protocol and doing things the way they really should be done, let's just set it up like that. But yeah, you can see it's actually doing exactly what I wanted to do, and everything is working as it should and perfectly synchronized. So that is how you go about rigging one of these machines. And that just about brings us to the end of this tutorial. So as always, I really hope you've enjoyed doing this one and that it's inspired you and you've got some ideas that you can use in your own projects. And if you have enjoyed the video, then please give it a like. And if you haven't already, please subscribe to the channel, leave a comment, and of course, ring the bell. And wherever you happen to be on social media, please do share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, that just about brings the curtain down on this one. So I'll see you very soon on the next tutorial.